This question is asking use direct integration to find the inverse Fourier transform of GC of f is equal to delta of phi f minus 2 delta of f minus 0.5. Now first we have to know the Fourier transform property. To find out the Fourier transform, this is the equation we are using. We are using GC of frequency domain, GC of f, and then here we will have a function of f within the integration negative infinity to infinity, a function of f, that is in this case that is GC of f, and we multiply that one with e power j 2 phi ft df. Okay, if you look at this one, and this is inverse Fourier transform. Fourier transform and inverse Fourier transform looks almost similar. The only difference is Fourier transform will be integrated with respect to time, so we will have a function with t, and then here we will have a function with t, and we will integrate that one with respect to dt. Here we are doing everything in terms of frequency, f. And also another difference, that e power for a Fourier transform, this is e power minus j 2 phi ft. For inverse Fourier transform is positive, e power j 2 phi ft. Okay, those are the difference. Now let's go ahead and do this. So here we have to just plug this function in this integration. We can put this function all together and multiply this e power j 2 phi ft, or you can start dividing this function right away, like negative infinity to infinity. Then you put the function, that is first function, that is delta of phi f, and then that is df, and then minus 2 is a constant, so we can put it in front, and then negative infinity to infinity f minus 0.5. But here we have to do one more thing. I missed one thing, that we have to multiply each of them by this e power thing, e power j 2 phi ft df, and then minus 2 integration negative infinity to infinity delta f minus 0.5 e power j 2 phi ft df. And here we have to know one property, that is when you have delta of at, that is equal to 1. Okay, let me write that with different color over here. One of the properties says that when you have delta of at, that is equal to 1 over absolute value of a delta of t. That is same to frequency domain as well. So instead of writing like this, we can also rewrite this as 1 over whatever the value multiplying, that's a. So here in this case this is the phi value. So we put the phi right here, and then negative infinity to infinity, and then this is delta of f. And now we have to see where does the frequency, like for a impulse function, it only occurs at if it t time is equal to 0, if it's frequency, when frequency is equal to 0. So here it only occurs when the frequency is equal to 0, and we don't have any shift or anything, so it's happening at 0. So instead of frequency here, f here, we can replace that one with 0, and then this t df. So if you replace this one with 0, that is basically e power 0. But to show that, you can take one more step to so that you are replacing f with a 0, and here minus 2 negative infinity to infinity and here the impulse function is happening at 0.5, because if you equate f minus 0.5 is equal to 0, then f is equal to 0.5. So this impulse is happening when the frequency is positive 0.5, f minus 0.5, and instead of this frequency over here, you can replace that one with 0.5 j 2 phi 0.5 t df. Okay, so once we replace this frequency here and here, this value becomes a constant because we don't have any f anymore. So we can write this as 1 over 5. We can bring this e power to the front. So here, if we multiply everything by 0, this is e power 0. E power 0 is basically 1. So you can write it as 1, or you can just show one more step and write e power 0 right here. Negative infinity to infinity, delta of f df. And same thing happens here. Here, this one become a constant, so we will have 0.5 is 1 over 2. So 1 over 2 and 2 cancels each other. So we are going to get e power j phi f over here. Okay, and this negative infinity to infinity, delta of f minus 0.5 df. And when you integrate an impulse function, that's equal to 1. So this one, this whole thing become 1, and this whole thing become 1. The integration of one is 1. So finally we will end up with, let me write the final answer right here, 1 over 5, and e power 0 is 1. So we can just keep it as like this, and minus e power j phi f. And this is our, and also we have a 2 in front, 2 e power j phi f. This is our final answer. Okay, I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.